Hi, I'm John Menti, one of the technical content developers here at Uptycs. In this video, we'll explore how Uptycs traces runtime threats back to malicious activities and artifacts within the software pipeline. When code is pushed as part of an image build, it undergoes a code review and PR process, CI/CD build process, and is stored in a container registry before being deployed in your Kubernetes and container environments. However, at any phase of this lifecycle, risks such as threats, vulnerabilities, malware, and secrets can be introduced due to missing security measures or malicious activities in your software pipeline. Uptycs Software Pipeline Detection and Response assesses critical threats by correlating runtime threats in your workload with the security posture and activity of your software pipeline, including all codes related to PR activity, GitHub security posture and code scanning alerts, Jenkins posture, and registry posture. This enables security teams to take actions and set preventative guardrails via CI/CD and runtime admission controls, allowing only safe code and image artifacts to be deployed. This ensures best-in-class workload protection and remediation through image provenance, integrity, and traceability. First, we'll start by looking at the malicious activity detected. We see that a reverse shell was detected with associated MITRE tactics and techniques. The detection graph shows us the reverse shell execution and that an XMRig malware was dropped. The command line ng server is linked to the reverse shell. Next, we'll examine the runtime container to determine what workload protection actions can we take. Navigating to the container, we can take action by looking at real-time processes, file investigation, scanning, and more. In this case, we can use the remediation actions to pause the container that is performing the crypto mining activity. What preventative measures and hardening can I implement to ensure these insecure images don't make it to my runtime deployment? For this, we can use image security policies and apply it in runtime as part of admission controls. I will copy this image name and add it to the image security policy that will block it at the cluster based on the image name and tag. We will see that the policy controls have kicked in and blocked this image from being deployed on cluster Uptycs-demo-admissions as part of enforcement. Next, we have some key questions to consider. Where did this reverse shell come from? Was some malicious code introduced or something changed in runtime? If this was introduced as part of the software build, during which part was it introduced? Was my software pipeline hardened enough? Or was there some key lack of security controls that led to this reverse shell? When we navigate to the provenance graph, Uptycs shows code to cloud traceability of this image, starting from release PRs in GitHub all the way to the runtime Kubernetes and container environments it's deployed in by clicking the runtime nodes on the right. We can also see the image is signed. Next, we will go from right to left to investigate where the reverse shell came from and whether our software pipeline was at risk and allowed this threat to enter. When we click Artifactory, we can see that anonymous access to artifacts isn't disabled so that the image artifacts can be tampered with. However, we still want to understand the origin of the image build, so let's look more left to the CI/CD build. There are Jenkins vulnerabilities on the CI/CD system, and this build environment is not configured to be logged, which could make future compliance and audits challenging. Still, however, we need to get a more profound idea of where this malware came from. That means shifting the repository and code. In the repository, we see that all PRs require 2 reviews. Moreover, we see that Uptycs can investigate GitHub security measures such as dependabot alerts and code scanning alerts to find vulnerable dependencies and other key risks in your code. While these are all valid and worth looking at, we want to see specifics about the reverse shell, which means we should now look at the code itself in terms of PRs. If we look at the PRs, we see that one PR has violations. Compared to all the other PRs, this one only has one approved PR, which means the GitHub branch protection rule we had was bypassed during the time of the code check-in. We should take a look at the code to see if something malicious was introduced. As we click in, we can see the same ng server from the detection graph and how the name of the original reverse shell was changed to masquerade it behind the process's name. We have finally found the source of our threat and can make sure we address the user who committed this malicious code. Well, that wraps up our overview of Uptycs Software Pipeline Detection and Response. Thanks for watching. For more information, visit uptycs.com.